Our next speaker is Abhisek Datta, the creator and maintainer of WET, an open source tool designed to help product security engineers with open source software components. With deep expertise in open source software supply chain security, he focuses on identifying threats and building tools to mitigate them. Today, he'll guide us through the critical topic of safely and securely consuming open source software, highlighting risks and best practices, and introducing us to his powerful tool WET. So let's welcome Abhishek to the stage.
Hey everyone, sorry for the technical glitch, and it's the last session before lunch. So there is one more session, is it? Okay, so but I'll try to make this interesting. It's a slightly different topic. Everyone here is using open source. Let's look at some of the interesting security aspect of open source. My name is Abhisek Datta. I'm the creator and maintainer of WET, a free and open source tool, security tool that I'm going to talk about today. I had been a security researcher in a past life, but lately more on the platform engineering side of things and more on the security defense side of things. Let me start with a question. Who uses FOSS? So everyone, right? So this is IndiaFOSS. I'm assuming that everyone is somehow associated with FOSS. Either you are already contributing to FOSS, using FOSS, or aware of FOSS, right? To give an analytical answer, I would quote Linux Foundation, which says, any modern software solution built today consists of 70 to 90% of FOSS in the final software that I'm shipping. Say, even if I build application using, say, Spring Boot or something, and I like write some, a million lines of code. Even then, the final artifact that I'm shipping would heavily contain free and a code from free and open source software ecosystem in terms of libraries that I depend on, libraries that I add, and their transitive dependencies. If you're familiar with SBOM, or if you really look into the software composition, you will see that every software built today has very, very high dependency on FOSS. Is there a cost to FOSS? It's free, right? Do you think there is a cost? I would say that if you are building software professionally, there is at least a security cost associated with FOSS. There is a cost of vulnerability, there is a cost of potential malware, and there is a cost of maintenance. The reason for that is this. You may be say a great software engineer, your code to bug count may be very low. But if you are responsible for running a professional software engineering team, then you would most probably not depend on personal brilliance. You would most probably architect a SDLC that maximizes the chance of your team shipping software which is secure and high quality, and minimize the chance of making mistake. Eventually you would do that. You would ensure that your team ships secure software. How can you guarantee the same for the open source libraries that you are consuming? If you choose open source dependencies that are at least as secure and as high quality as your internal code, you will end up maintaining the security and quality of the final software artifact that you are shipping. But if you choose open source libraries or open source components that are insecure or poor quality, even if you practice high quality SDLC within your organization, it will lead to you shipping software artifacts to your customers or deploying it in your infrastructure that has security issues or other challenges. For example, these risks are real. I'll give you an example of one of the commercial software pretty popular in the enterprise enterprises, where there was an unauthenticated remote code execution vulnerability because of a vulnerable third-party dependency in the authentication system. The fix was simple. All they had to do was upgrade to a fixed version of the library, right? But when you are using open source software, you have to deal with this. That's why there is a cost to it. There is a cost for you to maintain. There is also the case of malicious dependencies or malicious code getting shipped in newer version of dependency. For example, one of the popular libraries called ConnectKit, used in the the crypto wallet and crypto application, decentralized application ecosystem, was compromised and malicious code was shipped in a newer version. So by the time the security team of the company maintaining that library figured out, there was loss of approximately $600,000. So, and I'm sure how many of you are familiar with the XZ incident that happened some time back? Do you think it is scary? I think in general we got lucky, because someone who cares madly about performance saw a few microsecond delay and took the time to investigate, and something massive came out, right? If you are not familiar with it, I suggest definitely go and read at least what happened or what could have happened. So, if you care about shipping software that is secure and high quality, it's not that you can replace FOSS. FOSS is too valuable. It is irreplaceable, right? We all depend on FOSS. My security tool extensively depends on other free and open source code, right? We cannot replace them. But what we can do, we can adopt practices that will allow us to choose open source code, open source libraries and other components that meets our security and quality standard. That is the goal of building this project called VET, that really allows you to vet open source library for use. I'll talk about it. You'll probably see that it's very easy to use and integrate as part of your SDLC. So what is VET? VET is currently a CLI tool written in Go, built with the goal of implementing policy-driven vetting of open source libraries. I'll talk about the policy and how it helps. At a high level, VET's architecture kind of looks like this. Unlike most other security tools, VET does not have an opinion of what is risky, what is not risky. VET has components that that scans your application code base and package manifests like say pom.xml or packagelog.json, and identifies all the third-party dependencies that your application depends on. Then it uses data from public ecosystems, security metadata, to enrich those identified dependencies, and it just applies the policies. So if I have to say what is VET, what's so special about VET, nothing much. It's primarily a policy engine. It allows you to codify your opinion of safe and trusted open source components. If you decide that in your organization you don't want to adopt libraries which has a critical vulnerability, or you don't want to adopt libraries which is not maintained in say 2 years, or whatever criteria. Maybe I think OpenSSF has a booth here. They run a project called scorecards. You want to decide that for any library that you use, these are the scorecard criteria that we met. You can define them as policies in VET. Policies are very simple. I'll talk about it. And VET will ensure that any change in your third-party open source dependencies identified will be vetted against the policy that you define. VET policies are VET uses CEL, Common Expressions Language, as its policy engine. The reason for this choice is really expressions, because we have seen over time that policies may become very complex. So we wanted to ensure that our policy engine or policy language only has expressions and no statements or anything. And in general, we believe that cell helps keeps things very simple. So whatever your opinion of open source race, you can codify as cell expressions, and VET will automatically leverage that. For example, in this case, this is an example of a simple policy that identifies any packages with one or more critical vulnerabilities, right? I will not really give a demo of VET because I want to talk about some of the very interesting problems that we are solving and which you will most probably find very relevant. I would like to believe that VET has decent documentation, but happy to be surprised. So you can get started with VET using its GitHub project or using the documentation which is published. We also have some videos on getting started. VET also have a native CI/CD integration with GitHub Action. So if you're using GitHub Action as your CI/CD, you can get started with VET in 5 minutes. You can just add the VET action, which is a GitHub action, and it will integrate with your pull request, GitHub's action pull request, and it will vet any changes which is detected as part of the pull request, like any new library added or any new library updated, and it will vet those changes against your defined policies. This is how it will look like. It will add a comment as part of the pull request. Just like VET, most security tools are good at identifying problems. How many of you work in an organization where there is a separate security team who finds problems? How easy do you find it to fix those problems? Easy? Easy? Very easy? Difficult? Little difficult or very difficult? Right? The problem with security tooling is that it is generally easy to identify and hard to fix. Especially with the class of tool. VET can be kind of categorized into software composition analysis or next gen software composition analysis tool. Similar to say Dependabot or dependency review. If you use GitHub Advanced Security, then you might be using GitHub Dependency Review. These tools can find vulnerabilities very easily. Just like VET, what VET does, or VET or this kind of class of tools does, is they enumerate all the library versions that your application depends on, then queries a public database like say CVE or OSV to find all the vulnerabilities that impacts a particular library version, and then just gives you that list of vulnerabilities, right? So if you are using, again I'll give Java example, Spring Boot version X, VET-like tools, free or commercial, will query all vulnerabilities related to Spring Boot version X and just tell you these are all the vulnerabilities. So how many of you experience this, that every sprint or every cycle you have to update libraries to fix a lot of vulnerabilities? Do that? So you have to end up updating libraries. So do you experience challenge of updating libraries, that broken dependency graph, incompatible changes, can't update, bunch of things, right? Now if you really think about it, a vulnerability impacts some code in a library. In our application or say in a third-party open source library, there is some code that is vulnerable, right? Not the entire library. Some function maybe or some method in a class has introduced a bug which leads to a security vulnerability. Do I still need to update the library, spend all the engineering hours, all the effort, if my application does not even call that function? Right? This is one of the major area of work in next gen software composition analysis tools. This feature is kind of called reachability, but this idea comes from compilers. Right? The idea is that tools like VET will perform code analysis, parse your source code, as well as the source code of all the libraries, because it's easy to identify direct calls. Say you are using OpenSSL library and calling a function in OpenSSL library. It's very easy to identify that and parse and look for function calls and find that. But suppose you are using a library which in turn is using another library, which in turn is using another library. There is a full tree or a chain of call graphs, as we call it, coming into picture, right? Even then, ultimately you need to make a decision whether you should spend the time on upgrading a library. It's not easy to upgrade all the time. It requires effort. Should you upgrade? You should upgrade if your application that you are working on is actually vulnerable. So that is the problem that we are trying to solve with VET's reachability analysis capability. We have some ability to parse through source code. We use tree-seater library to parse source code. We can build the entire import reachability graph right now. So for Python application, Python-based application, we are also working on other language support. We can build a full graph of import reachability using which you can identify whether your application ends up importing certain Python module, right? Not just directly, but even transitively across all the libraries that exist in your application, right? We are working on the function reachability as well. What I mentioned, that some function is vulnerable, right? Not the entire library. So we are working on that part as well, where we can build a call graph at a part source file level, stitch them together across all the dependencies that you have and build that large call graph, and then find paths. Is basically reachability, right? Whether your application reaches a vulnerable function in some library, right? So that is one of the important, I would say, a high priority milestone, but it's a very hard problem. So if any of you have experience with code analysis and want to contribute, please come talk to me. I would love some help there. Another problem that we solve in VET is many a times VET reports that this particular library has a critical vulnerability. Developers who are responsible for fixing, they will come and say that I am not even using this library. I don't know. I have not defined it in my build.gradle or package.json or pom.xml. Nowhere I have defined this library. Then why is VET reporting this library, a vulnerability in this library? That is because when you add a library dependency, these libraries also depend on other libraries, right? So there is a complex network of libraries, or as they call it, transitive dependencies. In order to handle that scenario, what VET does, VET tries to reconstruct the full dependency graph. It adds relation. It say, for example, it detected a full list of say 200 libraries in use in your application. So it tries to reconstruct the relation, build the full graph, and trace transitive vulnerabilities in transitive dependencies to its top level dependency. Which dependency actually introduced a transitive dependency and in what level. So what is the result? So this is really the capability that VET has, but the result is something like this. If you use VET and if you use this group by direct dependency, VET will group all the vulnerabilities found in non-direct or transitive dependency by its direct dependencies, so that you can update only the top level dependencies that you as a developer control, and that not always but many a times will lead to upgrading the full dependency chain, right? It will lead to updating the vulnerable version of the transitive dependencies as well. So that is the goal of this particular feature. So in general, while we spent a lot of time in identification related things or improving identification, say for example you added a library dependency in one of your manifests like say pom.xml or package.json, and at some point in future you remove the code that uses that particular library. A lot of tools will still find or still consider that your application depends on those libraries and still report vulnerabilities in that. One of the things that we are working on in VET is actually look for code evidence, like actually look if a particular library that you have declared as a dependency is actually being used in your code, right? So the goal is to reduce the noise, actually give you the vulnerabilities related to open source libraries that are relevant for you, so that you are not bombarded with hundreds of such issue, which is a big problem today for this class of tools, which leads to only identifying problems and not fixing that. So all of this together is kind of leading to the changing focus of VET more towards the fixing side of things. So yeah, I think VET is an open source project. It's being actively developed. We do have a very small community of contributors and people who contribute code. We are actively working on the reachability analysis that I mentioned about code analysis to reduce the number of vulnerabilities and all these things. If you are interested, we have a booth, community booth upstairs, so please come and talk to me. Very happy to talk about the challenges that we are solving in the open source security ecosystem related to how you can consume safe and trusted open source libraries in your application. Yeah, thank you so much. I would love to answer any question. We still have some time. Would love to take any question if you have.
Hi, I'm Shiv. How different the VET is from dependable bot?
Sorry, from?
Am I audible?
Yeah.
Okay. My question: how VET is the product is VET, and how it is different from we have a dependable bot.
GitHub's Dependabot,
Yeah.
you mean, right?
Yeah.
So I think Dependabot primarily looks at two attributes. One is vulnerability and version updates, like version drifts. So VET looks at more data, like it allows you to really vet open source packages based on a lot more data, like OpenSSF scorecard, popularity related data, maintenance related information, bunch of things. And secondly, one of the unique thing about VET is really the policy language. You can define what is acceptable to you, right? The problem with security tools making decisions for you is that may not be relevant for your security needs. For example, Dependabot will probably raise a pull request even for a BDM or low risk vulnerability. You may not want that. You only want to care about critical vulnerabilities, right? So that is one thing which is different in VET, the policy driven approach. And second thing is that VET has a lot of focus now on code analysis. Like VET, we are trying to solve the reachability problem. We are actually parsing your code and trying to find out whether a particular vulnerability is relevant for your code and not just related to the version of the library that you're using.
Got it. But every organization widely using dependable bot because it's part of the Git offer. My question again, if it has a better features, so why still many organizations not aware of VET?
Dependabot kind of is aimed at solving the problem of dependency upgrade. Like if you read GitHub, I think they created that to build this habit of continuous dependency upgrades, right? So that you stay fresh. But you can check GitHub has a suite called GitHub Advanced Security. Under that, they have another product called Dependency Review, which is kind of towards what VET does.
Got it. Is there any plans to have a contribute together dependable bot and VET could be?
No, I don't think so. VET has a kind of different direction. VET's direction is more towards code analysis, reachability analysis, those kind of things, and more towards fixing now, because that is a larger problem. Finding, if you look at last 10 years, most of the security tools have invested in identifying issue. Fixing is hard.
it.
right?
Got it.
So vet's focus is kind of towards that, how to help mitigate the issue, because any cybersecurity investment actually gives you the value when you fix the risk, when the risk is mitigated, and that is the hard part currently.
Got it. What is your strategy to increase your wet to be more accessible to the wider communities?
Yeah, just talk about where show the value, and be open to features which the community needs. Like if you look at the last couple of releases, whatever we have shipped is specific ask from the community. Apart from code analysis, we mostly build features which the community asks, like this group by dependency I showed, right? That is a specific ask from some company which is using Vet. So we are very open to feature requests that helps real life teams who use vet, as long as it aligns with our goal of reducing false positive and fixing.
Got it. And you also have commercial version, or it's
We
purely?
don't have commercial version currently. It's entirely free and open source. We have plans to build a commercial control plane for vet, which allows you to deploy vet at scale and manage policy centrally. Vet is always going to be free and open source.
Thank you.
Thanks. Just to repeat, we have a booth upstairs. If you are interested in learning more about vet or want to contribute to any of these problems I spoke about, please come talk to me. Thank you so much.